So, this is what we need to talk about. An inscribed angle is an angle inside the circle with the vertex on the circle. Okay. Its measurement will always be half of the intercepted arc. So if this is 40, what is this arc?
Oh, wait, I was
20.
Yep. Yep. Okay. The arc is double, the angle is half. Okay. I like to refer to this as like the Pac-Man rule. Okay. Doesn't it look like Pac-Man?
No.
not really. No. He has a big mouth. I see it.
This is kind of relatable. Kind of looks like the Pepsi logo.
He's like, he's not. His mouth isn't in.
Yeah, his mouth isn't that big.
It's too far.
And it's like two separate things.
Like if this is Pac-Man.
That's not how it looks.
Forward a little bit.
Fine. Fine. I won't refer to it as Pac-Man.
Pepsi logo.
Pepsi logo. I see the Pepsi logo. Triangular.
Yes.
Oh, what's the intercept?
Okay, so when I say intercepted arc, it is the arc that the inscribed angle is eating. So if I am talking about this angle, then this arc is in the mouth of the angle. With that sound effect in your mind. Could you play it for me again? Nope. Okay.
You gotta draw a little tongue now. Well, he has a tongue. He has a tongue. He has a tongue.
He does have a tongue.
Like 40 degrees on.
Okay, at the bottom, draw this picture.
There's no point.
Wait, is this theorem 7.10?
Watch this. Watch this. Watch this one. That is not a big enough circle.
Oh, everything.
Oh, I don't.
Just draw it and then stop.
So it'd be 40, equal to the job. No, because I get it. 49 divided by 2. No, 47 divided by 2. Do you get 48?
Unless you want 20. And that's first period. Oh, yeah, actually, I hated having that first period.
Dude, yeah, that was a horrible first part.
Oh, yeah. I agree.
Okay, now, this angle right here intercepts the arc that is 96. So we're going to say that 2x plus 1 equals what?
196.
Half of 96, which is how much?
Half of 96?
Yeah.
Yeah, see, that's not our
48.
the intercepted arc. Wait, was he in our second grade? I just chipped over the balls. Yeah,
Okay, let's talk about that. So if we, so 2x equals 47, which means x.
Can you also just do that?
Hold on, I'm getting there. Wow. 23.5. I've had a lot of people ask, couldn't you just double it? Well, sure. You could say, hey, the entire 2x plus 1 can be doubled to equal 96. Here's the deal with this, though. You have to make sure you're doubling the whole thing. So since it's an algebraic expression, I got to make sure that 2 gets distributed to the whole thing. So 4x plus 2 equals 96. 4x equals 94. X equals 23.5. Yes, both ways work. You do what you feel is comfortable for you.
Why'd you like come?
Oh, because I was trying to figure out why my board looked so blank, and then I processed what it was that was missing.
What was missing?
What was missing?
What is missing?
Brackets.
Nope, that's not what is missing. I mean, those are like the due dates for like corrections and stuff because they're all passed.
No more corrections for us to school.
All right, now go to the next page, please.
They're making fun of him. No, we're not making fun of him.
Okay. Do you remember when we were in that computer warm-up, if we dragged the vertex along the circle, did the measurement change? If we took this point and we moved it, did the angle change? It did not, because the intercepted arc is what tells us the measurement. So what this is saying is it's saying, okay, if I have this blue angle here and this pink angle here, they are the same because their intercepted arc is the same. We know they have to be the same measure, okay? So, in this notes little portion here, could you draw this picture for me?
Yeah, I get that. I did the opposite side.
This makes what?
Oh no, I think I did this wrong.
This one you said to me.
Oh, so I hear, do we just set them equal? So they share an intercepted arc, which means their measures must be the same.
So add 3 minus 1, so x equals 3.
How do you draw a circle? I don't know how to draw.
You go down,
I don't understand.
right,
Appreciate
left.
you.
Okay.
It's literally down, right,
It's not
left,
really me.
right.
No, he's actually failing.
No.
Okay, hey Cole, this is what I would do. Can you watch my screen? Watch my screen. You have your circle, right?
Yeah.
Draw one angle like that. Do it now.
I have to erase what I had already. Wait, I got
He's
this
pretending
one.
he doesn't have anything.
Okay.
And then use the end points and draw a different angle.
I got it.
What? Okay. Okay.
Can I get that right? Oh, I gotta get the angle up on it. Fucking how do you do so much? You're really struggling to get that.
Hold on, buddy, let me do this over. No, I hate it.
Oh, yeah.
All right. Here we go. Okay.
That would be Arsenal. He's been waiting all year.
Please pay attention. Okay, so now we're going to talk about some theorems that involve inscribed polygons. An inscribed polygon means that each vertex is on the circle and our polygon is inside the circle. Okay? Okay, so I want you to look at this picture next to 10.12. Okay, what is AC?
A segment, chord.
Diameter.
It is a chord, but more specifically, it is a diameter.
On my way there.
Okay.
Talking about like 80 degrees.
If AC is a diameter, what is this chord, or what is this arc?
180.
That is 180. So, I'll wait. So we have a diameter, which means this is a semicircle, which means this inscribed angle
Oh,
is 90.
it's
Okay. So if we have a triangle inscribed in our circle where one side is the diameter, it's going to be a right triangle. Oh, I'm glad that you're pretending to pay attention now.
Explain it to you. So like basically in the circle when AC is the diameter, when the hypotenuse is the diameter, then and it looks like a right triangle, then ABC angle ABC is 90.
That's not how we got to it. Though. We're not drawing anything.
You are drawing this in the notes under that theorem.
Theorem 10.12.
Okay, I would like you to draw this. Drawing does not mean you need to chit chat. Okay, so I want to know the arc measure of AB. In order to do that, what do we need to figure out? So angle ACB. Now, if this is a diameter semicircle, then we know that this is a 90-degree angle, which means, what is this angle? So that's supposed to be a 5.
Wait, 65.
That's 25.
So this is 65 degrees, which means the measure of arc AB would be obviously this is not drawn to scale, and I apologize for that.
Can we just find the measure of CB and then just 180 minus 80?
Ah, okay. Alex has a second way we could have solved this. He's saying, hey, isn't arc CB 50 degrees, which means we can take 180 minus 50 to get 130. Yes, that would work. Just put it on my chair, on my chair, on my chair. This angle is 65, and then we double it to get the arc.
Oh, okay.
Oh. Yeah, I did.
Okay, our last theorem.
You did it. Because I got myself in.
Are you ready? If a quadrilateral is inscribed in a circle, How many sides does a quadrilateral have? 4.
Quattro.
Wait, what?
We're good now. Hey, guess what? It's not your business. Opposite angles are supplementary.
Doesn't that make them?
Doesn't that make them what?
What?
I don't know.
Wait a second.
Doesn't that make it a like a kind of letter?
Wait, so then DEF. Yeah, I got it. I got it. I got
Okay, can we talk about why?
Because opposite angles if they're supplementary.
So, what's true about these two?
There's 4.
What?
Okay, so there we go. The arc that FED intercepts and the arc that FGD intercepts together would make 360. So, together the angles would have to equal 180. Ah. Okay, last example that you're going to have to draw.
Wait, it kind of does look like
Hi. You said something.
Hi, JK.
Shut up. Wait, that's kind of funny. I guess it was. You're still laughing. This is funny.
So funny. You don't want to get your student journal out? Okay, so what this means is that x plus 78 equals 180. What does that make x?
102.
It also means that 3y plus 30 added to 2y plus 10 is 180.
That's why I got -4.
So 5y equals, so y equals
28.
No.
28. I can't believe
Yeah.
I didn't say that.
It's 28.
28.
Wait. And what are those two?
5y plus 40 equals 180.
130.
Yeah, and then subtract 40.